Okay, so we're on the last video then of these spanning sets kind of problems, and yeah, this taking a little longer than I thought it would, but I forgot to pull up the problem on a different screen, so I don't actually know what problem I'm doing right now. Give me a second. Okay, so this is 4,440, and the problem is this. So if P1x is equal to x minus 4, and P2x is equal to, this is a minus sign, is equal to x squared minus x plus 3, determine whether P of x is equal to 2x squared minus x plus 2 lies in the span of P1 and P2. Okay, so what does this mean? It just means that if I have a linear combination, if I do like A times x minus 4 plus b times x squared minus x plus 3, is there an A and B such that this equals 2x squared minus x plus 2, right? And what is this actually? Well, this is actually a system of equations problem, kind of. Actually, it is a system of equations problem. How do we set this up? Well, this is an important skill to have, but we need to turn these polynomials, right? We need to turn these guys that don't look like vectors into column vectors. And how I'm going to do that? Well, let's do this. Here's P1x. All right, let's turn it into a column vector. How am I going to turn it into a column vector? Well, I'm going to have this first entry correspond to the constant term, right? So it's going to be whatever times 1 goes into this first entry, into the first component, and then the second component it's going to be x, all right? And then in this third component, it looks like it has to be x squared. So P1, for example, is equal to negative 4, 1, 0. Why is that? Well, it's because I have 1 times x, okay? 1 times x gets me x, and negative 4 times 1 gets me negative 4, all right? So yeah, that's how I turn then these vectors, these polynomials into vectors, right? And you get P2x is equal to, well, this then becomes 3, negative 1, 1. All right? And it doesn't matter how you actually like write this. You can write this guy here. You can write it as 0, 1, 4, 0, 1, negative 4. But you have to be consistent. You must be consistent with how you write it. And I'll usually do it as constant term, first order term, and then the square term. And there's a reason I do this. I think the book does this. And the reason why you want to stay consistent will come up 2 sections from now. So just do it out of good habit. All right. So yeah, so it doesn't matter. Just stay consistent with it. All right, so what does this mean? Well, notice if I do negative 4, 1, 1, 0, 3, negative 1, 1, and what happens if I multiply this by a, b? Oh, wait, yeah, this is equal to then, this is equal to negative 4a plus 3b. This is equal to a minus b, and this is equal to b, right? But if I extract a's and b's out separately, that's a times negative 4, 1, 0 plus b times 3, negative 1, 1, right? And so, yeah, look, what do we want this to equal? We want to see if this equals 2x squared minus x plus 2, so that's 2, negative 1, 2, right? So is there an a and a b that makes this happen? And sorry about this. This part is actually super redundant right here. But it's okay. So essentially, it just means, is there an A and B such that I can get this to work out, right? Is there an A and B that I can make these two vectors add up to each other? And what does this look like? This looks like a system of equations. So yeah, we gotta put this into a matrix then. And I do 4, 1, 0, 3, negative 1, 1. and this becomes an augmented matrix where I want to see if there's an A and B such that this is equal to 2, negative 1, 2, right? And what they do here, we row reduce. So 0 out that guy. How do I do that? It's actually kind of a pain, isn't it? So we're actually going to switch columns. We're going to switch rows first. All right. And now I'm going to 0 out this 4 because I don't like dividing by 4. I don't like dealing with fractions. And so what do I get? I get 1, negative 1, negative 1. This becomes second row plus 4 times the first row. 0, negative 1, negative 2, 0, 1, 2. Oh, would you look at that? Well, the second and third row are linearly dependent, and so I can just kill one of them. I'm going to kill the second row, and so we end up with that, right? And what does this mean? It means that it is consistent. Why is it consistent? It's because here's a pivot, and remember, I can find then what B is. I can see that B is equal to 2, right? And then that tells me that A minus B is equal to negative 1. So A minus 2 is equal to negative 1. And then A is equal to 1. So I know B is equal to 2, A is equal to 1 satisfies satisfies this equation right here. And so that means that this polynomial lies in the span, right? And this is how you do this kind of problem then, when you want to determine if a vector lies in a span or not. It actually just turns into a system of equations problem where you have to row reduce and find see if the system's consistent or not. Because if the system's consistent, you're good. If it's not consistent, then you have a problem. Then the vector doesn't lie in the span.